Welcome to SMART Notebook Math Tools. Today we're going to look at how to use the protractor and see what has been added to its functionality. If we click on the secondary toolbar for the measurement tool icon, you will see the 4 measurement tools displayed: the ruler, the protractor, the geodriac, and the compass. And if we click on the second icon, we'll get the protractor onto the workspace. And as we hold a dark shaded area in the middle, we can move that protractor around in our workspace. Clicking on the small circle on the bottom, we can change its view to a 360-degree view. And re-clicking on that small circle, we can default back to the 180-degree view. If we trace along the edge with a marker pen, you will see a smooth arc appear as I draw along the outer edge. We can rotate the protractor by holding the outer circle of numbers. And as I rotate, you see the angle displayed in the center circle as our angle of rotation. And notice that it stays vertical so that we can read our angle measure quite easily. Clicking on the dark shaded region, we have appear an angle ejector arrow, a little green arrow, as well as a green circle. And as we hold that green circle and rotate around, we see our angle measure displayed in the center circle change. And then as we click on the green arrow, we eject out that angle that's been measured. Holding the circle of numbers in the middle, we can pull the protractor in and out to resize. And finally, we have a pull down menu. By clicking the downward arrow, we see that we have the features that other tools in Notebook have. So what has been changed from using the older version of Notebook to newer version? We could get a protractor from the gallery in the older version, but it was at least 4 touches away. We had to use 2 different protractors to measure in opposite directions. Resizing the protractor changed the pivot point, which could be very problematic. And using a pivot point was not how we would naturally interact with a protractor in the older version. In the newer version, we found how easy it is that in 2 touches, we could have a protractor onto the workspace. The one protractor could be used to measure for opposite directions. Resizing the protractor did not change the pivot point, which is a very good new feature to add. And it acts on a pivot point at the vertex. Now let's see how some of this functionality can be applied in an example. Given similar triangles, verify the equality of corresponding angles and the proportion of corresponding sides. So we could use our measurement tools, the ruler and the protractor, to do this. Clicking on the measurement tool icon and then on the ruler and pulling with the dark shaded region in the middle of the ruler, we could move our ruler onto the workspace and measure our side lengths. Okay, at this time, I'm going to just work with the protractor. So deleting the ruler by clicking on it, I can either use the delete button from the toolbar or use the pull down menu. Now clicking on the measurement tool icon again and clicking on this, sorry, that is a little bit off. So clicking on the secondary toolbar again and clicking on our second icon for the protractor. Again, holding the dark shaded region, I can move my protractor and place it anywhere in the workspace, so at one of the vertices or at a vertex of one of the triangles. As I move my green circle around to the other side length in the triangle, I can measure my angle. And as I click on the ejector arrow, I see that I've measured the angle to be 122 degrees. Using another protractor, so clicking on my protractor, I can either go to the secondary toolbar or just clone this one. Okay, so there I have a second protractor to use, and placing it on my other triangle, and then clicking on the ejector arrow, moving my little green circle around with its arm to the other side length, and then clicking on the ejector. Actually, I'm going to resize this protractor before I do that, so that when I click on the ejector arrow, I can see that angle displayed as 122 degrees. So here I've measured two angles, two corresponding angles, and they are equal in size. Now I'm going to delete this protractor using the pull down menu and delete, so that I have more room on my workspace and I can use that to measure the other angles. So moving my protractor to one of the other vertices. Okay, now I can move my green circle down to one of the side lengths, and I can move my white circle around so that I can measure that angle between two of the sides in a counterclockwise direction. So if I read now from the left side of the protractor, it looks like I've got about 21 degrees there. And as I eject this angle, I see that I've measured that angle to be 121 degrees, or sorry, 21 degrees. All right, to measure my third angle, let me move my protractor actually to the other triangle so that I can see how we can do this. Rotate around so that I can place the protractor onto the vertex at the pivot point and line those up. Rotate my protractor so I'm along one of the side lengths. Okay, still going to have to match up that pivot point to the vertex. There we go. A little bit more rotation. There we go. And now resizing the protractor so that as I measure, so moving the white circle around to one of the side lengths and moving the green circle around to the other side length, I can measure from in a counterclockwise direction as I move from the white circle to the green circle. Ejecting that angle, I have measurement of 36 degrees. Okay, we can also look at other properties of the triangle, such as placing the 36 degrees, 122 degrees, and the 21 degrees, and looking at the sum of the angles of the triangle, and we have it pretty close to 180 degrees. The accuracy is going to be similar to what the students will actually work with real protractors, trying to get that accuracy. And for the SMART board, this depends on trying to line up that vertex with the pivot point. In the next example, we look at a protractor and use it for describing the properties and relationships of angles formed by parallel lines cut by a transversal. In this example, it's going to be good to see how easy it is to set up a question. So here, we're going to use our ruler to set this one up. Move it onto the workspace by holding the dark shaded region and dragging. We're going to rotate this ruler a bit so we have a little bit of a more creativity to this example. So here we have a line that's not horizontal. Okay, that didn't quite work. So let me delete that line for a minute. Pull that back onto the workspace. try that again. So holding the marker along the ruler, there we go, along the edge. Now, as I move the ruler up, I know that the angle of rotation is already 12 degrees, so that as I draw another line, I have a parallel line quickly set up. Then as I move the ruler down and rotate it, and then draw a line, I create a transversal that intersects my two parallel lines. Clicking on the ruler, using the delete button on the toolbar, I can now see my example set up quite quickly with a diagram. Using the secondary toolbar measurement tool icon again, I click for and select for a protractor. And now as I pull this with holding the dark shaded region onto the workspace, line up the pivot point with a vertex, rotate that protractor, so rotate down until I line that up. Okay, and there we see that as we line up the protractor, the angle displayed is also 12 degrees in that center circle. So I'm ready to start measuring the angle. So pressing on the dark shaded region, I have an angle eject arrow, holding the green circle and rotating it around to the transversal. I can now measure that angle. As I eject the angle, I have about 47 degrees. Moving around to the next angle. So as I move this to the other side, and as I move my white circle to my transversal, I can now measure my angle between the white circle and the green circle, the two arms. And as I eject that angle, I have 133 degrees. So you can see here that with the accuracy you can get sometimes, you have supplementary angles as they add up to 180 degrees. Clicking on that circle for a 360-degree view, I can just continue around to measure my angles. And so as I hold the green circle and drag to the transversal, and as I hold my white circle and drag around to one of my parallel lines, I can measure in a counterclockwise direction the angle between the two arms and eject that, and I've got an angle of 47 degrees. So the opposite angle, you can see, is the same. So opposite angles are equal, so that property can be discussed. And as I continue to go around and move my arms with a white circle and my arm with a green circle, so that I can measure the angles. Okay, and then eject that angle. I have an angle of about 132 degrees. So a little bit of the problems this children will have with actually using a protractor for accuracy. And there we have 132 degrees. Okay, clicking on the circle to return to a default 180-degree view, I can now move my protractor up to the other vertex and try and measure the angles that are alternating and corresponding with the previously measured angles. Okay, so here we start to measure. All right, so I have as I eject this angle, I have 47 degrees. So we have corresponding angles already. And let me just go to all the way around and see if I can measure one of the alternate angles. Okay, and there, let me just get a little bit more accuracy on this one if I can. There we go. And so as I click for this measurement, I've got 46 degrees. Actually, I can probably get better accuracy here, so I'm going to delete that angle. Whoops. Which angle was that? 46 degrees. Let me just look at that angle again. Try for better accuracy here. And eject that one, and we have 47 degrees. All right, so here, I'm just going to delete my protractor and start to explore some of these angles. And so as I look at the two alternate angles, I can see that the alternate angles are equal 47 degrees. And as I look at one of the two corresponding angles, again, I can see there's an equality of corresponding angles, 47 degrees. Stay tuned for our look at how to use a compass in our next session.